All right, so that is Leo the Lion. Um, all right, and let's go again. The constellations are regions that have been named, um, in and in modern times the actual boundaries of these constellations have been well defined. Um, so nowadays the entire sky, including the southern hemisphere, there are 88 total um, internationally recognized constellations. So that there's 88 of them. All right. And by the way, we don't have to, it's not like this class is not about memorizing the constellations. We use the constellations in the sense that, when we talk about a particular direction, right? Like this bright star right here is it's in the direction of Cygnus. This is called Cygnus the Swan, by the way. And it's so some of these have very recognizable features. Like for example, Cygnus the Swan is also known, or this part of it right here, as you can see there's some bright stars, and there's this looks like a cross. In fact, this is often called the Northern Cross. And coincidentally, in the summertime, you can look almost directly overhead, and you can see Cygnus, Cygnus, or this what's called an asterism, as I mentioned before. The asterism would be the cross, right? Cygnus would be the entire constellation, but this very easily recognizable part of it is called the Northern Cross. There's actually a Southern Cross as well. Um, all right, so that's it, and this is the picture that some ancient peoples imagined that they saw in the sky. Um, Remember, this is before long before television or movies or anything like that. So they just looked at the sky and they used their imaginations. And sometimes there was some pretty crazy imagination stuff going on. All right, now let's turn to the astronomy. So there is daily motion of the night sky, and then there's annual motion of the night sky. The year, so every single day, of course, one of the things we notice is the sun rises in the east, and then it'll set in the west. The moon does similar things, although the moon, when you can see the moon, sometimes it's not always in the west. Okay. Because the moon has its own motion, and then the planets. Okay, so the planets, we'll talk more about those in a little bit. But let's take the sun for example. The daily motion of the sun from the east to the west is just a result of the rotating Earth, right? So this daily motion that we're talking about, which is also known as diurnal motion, just to let you know, there's the word right there, daily motion, comes from the rotating Earth, right? And the sun is moving through the galaxy, but we're moving along with it, right? So the fact that the Earth is turning on its axis, that's the daily motion, right? That's this arc that the sun makes in the sky. Sometimes that arc is higher in the sky. That's what we call the summertime. Sometimes that arc is lower in the sky. That's what we call the winter time. We'll get to that a little bit later as well. Now, the moon makes a very similar arc, not exactly the same arc in the sky, and so do the planets. Okay, so they and now the moon and the planets are going to be, the moon especially is going to be in different locations on a different night, on different nights. For example, you go out, let's say you go out on a Monday night, and let's say that the moon is in the eastern sky. Let's just say that, like, you look at the moon, it rises in the east. that's actually going to be much closer to what we call a full moon, which I'll get into the phases of the moon a little bit later. That's part of this chapter. But anyhow, if the moon is in the east, on a particular night, let's say, and let's say it rises at 8 o'clock at night, wherever you are, right? Let's say you're in a particular location, you go out at 8 o'clock, and you just notice that the moon is just coming up over the horizon, over the eastern horizon. Now, the next night you go out, it'll almost come up at the same time, but it'll actually come up a little bit later. All right. And then the next night after that, a little bit later and a little bit later and so forth. Okay. Because the moon is, of course, orbiting the Earth. So it's going to be at different positions. The planets, are a little bit more complicated. We'll get into the planetary motions, a little bit later. But in general, in a given night, the planets just follow the rotating celestial sphere. So the celestial sphere moves from east towards west, right? So actually, remember what that means. In reality, that means that the Earth rotates from west towards the east, right? We're spinning towards the east. That's why the sun rises in the east. All right, so that's the daily motion that has to do with the celestial sphere. Now, the annual motion has to do with the Earth revolving around the sun, right? It takes 365.24 days. That 0.24 days is really important, by the way. I want everybody to understand it's not a perfect 365 days. In fact, it's not exactly 0.24. It's very close to that number. But at any rate, that value is important in the different stars that you see in different parts of the year. You might mention, let me go back just a little bit. Like, for example, let's say around midnight, you can Cygnus the Swan is, let's say, directly overhead on, let's see, it's usually around, usually around July or August. You can see it really close to directly overhead. It depends on where you are on the Earth, but in the northern hemisphere, it's really close to directly overhead. And then as time goes on, the Cygnus the Swan will not be directly overhead. At the same time, let's say you go out there at midnight and it's directly overhead. A month later, you go out and Cygnus the Swan has shifted noticeably. Okay, so each night it moves a little bit, but over the course of like a month, you can very noticeably say, oh, hey, it's not directly overhead at midnight. It's going to be directly overhead, let's say at 1:30 in the morning, right? So where it has shifted towards the west, and that's just the Earth moving around the sun. Okay, that's what we mean. Let's see, that's what we mean by. I'm just getting mixed up here. That's what we mean by annual motion. All right, so let's go into this in a little bit more detail. So the daily motion is the different objects in the sky. Let's say you're out and it's nighttime. If you look in the night sky, the stars and the planets all move from east towards west. Again, that's the Earth rotating the other way. All right, so that's a good way to look at it. The one thing that is always constant, and now you have to be you don't have to be exactly in the northern hemisphere. You could be like a little bit south of the equator to see this, but it depends on what you're what your latitude is, but I mean, you can't be too far south. You can see what's called the North Star, right? The North Star is that somewhat bright star. It's not, again, not the brightest star at all in the sky, but what's important about it, all the stars rotate around that North Star. All right. So if you're in the northern, especially if you're in the northern hemisphere, you can clearly see the stars rotating around the North Star. Not, this is over the course of an entire night. You're seeing this, right? So there is this thing, of course, called the celestial equator. It's just the Earth's equator projected out onto the celestial sphere, right? So imagine you got the Earth's equator, you project it out onto the celestial sphere, and the same thing goes with the poles, right? The Earth has, of course, a North Pole and a South Pole. If you project the North Pole out into space, that's called the North celestial pole. And this thing, the thing that we call the North Star, is really close to that. And so that's why it's no matter what time it is of day or night, but well, I mean, in day you're not going to see the North Star, but at nighttime you're going to see the North Star, and it's always in the same position, right? The only way that changes is by changing your latitude, right? Like for example, if you're on a ship, or if you're crossing a continent from north towards south, or from south towards north, that's the only way that you're going to change where the North Star is, right? In the sky, but the North, all the other stars rotate around the North Star, right? And they're all moving from east towards west. Again, that's because of the Earth's rotation. All right. So now in the South Celestial Pole, if you were to go, below the equator, that's the only way to see in that direction. There's no bright star that lines up with the Earth's with the South Celestial Pole. There just happens to be a bright star, again, not the brightest star, but a bright enough for humans to see it, without a telescope or anything like that. In the South, on the South Pole, of course, there's stars in that direction. There's lots of stars everywhere, no matter what direction you look. But there's no bright star that you can just look up in the sky and see. You'd need a telescope, but at least binoculars or something like that, to see any stars that line up with the South Celestial Pole. All right, let's see. So the Earth's equator, I talked about that. All right, let's move on to the next slide. All right, so this is what I was mentioning before. Okay, so let's say the constellations are always in the same order in the sky, right? Like for example, Gemini is always, as you're looking at it, is always to the left of Taurus, right? But so like this is a great example. On June 1st, let's say it's sunset, and you notice, let's say the sun is actually in the constellation Taurus. And by the way, the constellations that the sun passes through are the constellations of the zodiac, by the way. So what's going to happen is right after sunset, you can see Gemini, but then a month later, the sun creeps into Gemini. Of course, it's the Earth going around the sun that's causing this, and then you won't be able to see Gemini right at sunset. So a month later, after June 1st, it's July 1st. You can't see it anymore, and you'll be able to see Cancer. And Cancer is, of course, always to the left of Gemini, just like Leo is to the left of Cancer. And so, a month later, the sun is now in Cancer, and you can see the stars of Leo setting. So this is right at sunset. All right. right? That's the idea, all right, of